All right. This one I'm going to use, I'll use the actual symbols, right? So omega, initial angular velocity, final angular velocity, alpha, time, right? Okay, I'm also going to use these tangential relationships here, right? So I've got the radius is 0.34 meters. So notice its diameter. I almost did this wrong, right? So I divided that by 2, right? Okay, and then I'm going to use for the acceleration, it's 3.6 meters per second squared. So the angular acceleration is a over r, right? So the angular acceleration is 3.6 divided by 0.34. 0.6 divided by 0.34. 10.588. Okay, and then the car is going from 12 meters per second, right? So I'm going to use the angular velocity is linear velocity over r, right? So this is 12 over 0.34, which is 35.294, and that's radians per second, right? And then the final velocity is 32 meters per second, so that's 32 divided by 0.34 to get the final angular velocity, right? So 32 divided by 0.34 is 94.118. And that's radians per second, right? And then we want to know what the angle is, right? So I guess we'd use no t, right? So v squared is u squared plus 2as. So 94.118 squared is 35.294 squared plus 2 times 10.588 times the displacement, right? So that guy squared minus this guy squared is that, and then divide by 2, divide by that. I love this up arrow thing on the calculator. Okay. And I get 359.47. Or I'm sorry, this is really our theta, right? It's 359.47, right? So I really should have used the formula omega final squared is omega initial squared plus 2 alpha theta, right? Okay, so this is my theta. My theta is 359.47, so we've got that. And then we want rotations, right? So just divide by 2 pi. Divide by 2 pi, right? Divide by 2, divide by pi. 57.2 radiations. What am I saying? 57.2 rotations. We get a little loopy here. All right. All right. That's great. This was a lot of conversions. Let me show you an easier way to do this. Okay. So let's just figure out the distance the car goes, SUV AT. Initial velocity is 12, final is 32. Acceleration is 3.6. V squared is u squared plus 2as. So s is what? V squared minus u squared over 2a. So it's 32 squared minus 12 squared over 2 times 3.6. So we just soup out this. Literally soup out the linear stuff. I'll show you what to do. So 32 squared minus 12 squared divided by 2 divided by 3.6. Because the linear distance is actually 122.2 bar meters, right? And then the angle will just simply be s over r, right? So that's going to be 122.2 bar divided by 0.34 is our radius, right? So divide by 0.34, and I get 359.47 radians, right? Which I can then divide by 2 pi and get 57.2, right? So sometimes it's easier to just do the linear thing and then at the very end go into angular land. Just saying. A lot of ways to do these. They're some of my favorite problems.